first time that at Montclair that they had actually to turn in proofs. I don't know how they ran that class before I got there, but students hated it. You can still see their comments on Rate My Professors. I think that was up already back then. How much they hated writing proofs, and I was making them do this, and so it must be my fault. And there was one kid in the class that was always getting him right, LaTeX up his proofs. And when you LaTeX up a proof, it looks like it was easy. And they said, well, Charles has an extra edge because he just knows more. And then one day he came to my office and he said, what they don't know is I stay up all night doing this. It's a lot of work, and they have no idea how much work I put into it. And so I thought to myself, like, that would be a great message to tell everybody this is just a lot of work. It just is. It's not necessarily that you can't reach it. It's just, it takes more of your brain power to think it through. All right, so now I'm going to show you that this is not uniformly continuous. So what I want to do is take a sequence, 2n pi, and yn equals 2n pi plus pi over 2, for n well, what I know for n large enough this difference well, not the algebra is true in general. Okay, some more pre-calc. You do this a lot. You rationalize the numerator. Let me not do two. I'll split out the steps. Actually, you do this in calculus. When you do limits, that very beginning of calculus, when you're doing limits of weird things, you multiply top and bottom by the conjugate. Remember that?
Polish. You like to make a joke that it's Polish one. You multiply the fraction by 1, but it's Polish because it's all complicated.
So he would like my math, where 2 is equal to 1.
Oh, yeah. He was funny. He had tongue cancer. He had to get his tongue removed before I met him. Yeah, super cool dude. So I'm not making fun of him at all, but he sent us an email over the summer like, hey, listen, when you get back, my voice is going to be crazy. And he would start out every day like, this. Once you got used to it, he was an incredible teacher. He's the reason I'm a math major.
I did tell him.
I did. He wrote my letters of record for us.
The problem with all this algebra is you finally stop understanding is do you have this? Did I lose something here? 2n pi, pi. Oh, I lost an n here. So this is going to cancel out the top here. You're just going to get a minus pi over 2. And the bottom part is going to turn out to have n's in it. You could have also done the highest power and use a limit argument. And so what happens is the bottom gets really huge. And so you know this thing is converging to 0. And so you know that for really large n, this thing can be made small. So you did do this in high school or wherever you took calculus. There were certain limits that you had to take, and you rationalize the denominator or numerator. You also might have done it in pre-calc, but I think in pre-calc you rationalize the denominator, not the numerator. You always try to get the square roots out of the denominator. So it's the same process applied to the numerator. So all I did was I took xn minus yn. I guess I can put my absolute values back up. Rationalize the numerator. And I got that. So xn minus yn can be made arbitrarily small. But no matter how far apart those xn and yns are, I have sine of xn squared they're multiples of pi and a phase shift of pi. So you really have multiples of pi, sines equal to 0. You have multiples of pi in there. And sine yn squared is equal to 1. So 1 delta won't work. Did I put a 2 in here? Yeah. Right? We're just cosine. Shift it by pi over 2, you get cosine. Trick. So if you chose epsilon to be 0.1, there's no way like this. You can't find a delta that's independent of the epsilon. So you can make this arbitrarily small. The distance between the x and y arbitrarily small, but the distance of the y stay far apart. So any different choice of x's is not going to give you 1 delta. I think some of you graphed this when I first showed you. You can see the wiggling, the amplitude's changing as you start this let x squared scoot up to the right. The amplitude, the frequency was changing, so you got like a lot of close together things. So it's like really that the function has different distances on the x-axis as you go across, just like x squared. That's what Dr. Moen showed you, is the x squared. The problem with x squared is that as you go down to the right, like where you are on the graph actually matters. You can't just pull out the x minus c and have 1 delta. So the other one gave you insight. The proof of continuity gave you insight that looks like it has to be a function of epsilon, your delta, and this shows you why. Yes, you do.